VIT University, Assembly Lab 212, and what I have with me is a spectrophotometer, and this is a cuvette in which the sample is poured, and this cuvette is placed in this compartment over here. And what we have over here is a display panel which shows you the absorbance or the OD value of the sample, and the panel over here shows you allows you to control the wavelength at which you want to set your spectrophotometer to.
So talking about spectrophotometry, we all know it's one of the most useful methods of quantitative fields such as chemistry, physics, biochemistry, material and chemical engineering. A UV visible spectrophotometer is an instrument which measures light absorption as a function of wavelength, both UV region as well as visible region, and it is used to measure the amount of light that is absorbed by the solution which is placed in the cuvette in the spectrophotometer. Now let's talk about the history of the UV visible spectrophotometer. In 1935, Arnold O. Beckman founded the National Technologies Laboratory, which was later named as Beckman Instruments. In 1941, Beckman introduced the UV visible spectrophotometer, which had higher resolution and lower stray light in the UV region than any other commercial instrument. In 1946, Carey Instruments was founded by Howard Carey, George W. Downes, and William C. Miller under the name Applied Physics Corporation. Previously, Howard Carey was the vice president in charge of development for Beckman Instruments. In 1947, the Applied Physics Corporation delivered its first commercial available recording UV visible spectrophotometer, which was the Carey 11, to the Mellon Institute in Pittsburgh. In 1953, Bosch and Lomb introduced the Spectronic 20 UV visible spectrophotometer, which was the first mass-produced low-cost UV visible spectrophotometer. In 1954, Applied Physics Corporation launched the Carey 14 spectrophotometer, which was the first double beam commercially available spectrophotometer. The double beam design greatly simplifies and speeds up the sample analysis by simultaneously measuring sample and solvent transmittance over the wide spectral range of UV visible wavelengths. UV visible spectrophotometer works on the principle of Beer-Lambert's law. According to Beer-Lambert's law, there is a linear relationship between absorbance and concentration of an absorbing species. Absorption, which is denoted by capital A, is directly proportional to the path length and the concentration. Path length is denoted by L and concentration is denoted by small c. Transmittance, which is denoted by capital T, depicts the fraction of light that passes through the sample and is equal to I divided by I naught. I is the intensity of the incident light, whereas I naught is the intensity of the transmitted light. By using mathematical equations, we can relate A and T by A equals to minus log of T and which is equals to minus log I by I naught. Now let's talk about the instrumentation of the UV visible spectrophotometer. The components of a UV visible spectrophotometer include a source, a monochromator, a sample compartment, a detector, and a recorder. The block diagram given here summarizes the basic working of the UV visible spectrophotometer. Light emitted from the source passes through the wavelength selector, and the light from the wavelength selector passes through the solvent, which is the sample. The light that is transmitted from the sample passes through the photodetector, which then passes a readout device which measures the OD value of the sample. The UV visible spectrophotometer has two light sources. For the visible range, tungsten is used as the light source, and for the UV range, deuterium or hydrogen lamp is used as the light source. Light from the light source consists of various wavelengths, hence it is known as polychromatic or heterochromatic wavelength. And the problem which is faced tungsten light source is that its life period decreases due to the evaporation of tungsten. This problem is overcome by using a tungsten halogen lamp. Since the light produced by the source is a heterochromatic radiation, the monochromator does the job of producing radiation of single wavelength either by refraction through a prism or by diffraction by grating. Earlier spectrophotometers used prisms, where for UV prisms were made out of silica and quartz, and for the visible spectrum, prisms were made out of glass. Now they are replaced by diffraction grating. The diffraction grating is made by drawing lines on a glass with a diamond stylus. Cuvettes are transparent cells. The sample is first poured in a cuvette and the cuvette is then placed in the spectrophotometer. Cuvettes made from glass and plastic absorb UV light which is below 310 nanometer and hence can't be used in the UV region. Cuvettes made from silica and quartz do not absorb light in the UV region and hence can be used in the UV region. A photocell is a photoelectric device which converts light energy into electrical energy, which is then amplified, detected, and recorded. What we can see over here are the different UV visible spectrophotometers present in the different labs of VIT University. Here's how a spectrophotometer works. A lamp provides the source of light. The beam of light strikes the diffraction grating, which works like a prism and separates the light into its component wavelengths. The grating is rotated so that only a specific wavelength of light reaches the exit slit. Then the light interacts with the sample. From this point, the detector measures the transmittance and absorbance of the sample. Here we see the working of the UV visible spectrophotometer visually. The light emitted from the radiation source passes through the slit. From there, the light is passed on to the diffraction grating, which converts the polychromatic radiation into monochromatic radiation. This monochromatic radiation is put to the sample, and then the OD value is shown by the recorder. Advantages of UV visible spectrophotometer. It helps in detection of functional groups. It also helps in the detection of impurities, quantitative analysis, single compound without chromophore, drugs with chromophoric reagent. It helps to show the relationship between different groups. It will also detect the conjugation of the compounds.